Okay guys, so today we'll be doing the function pointers, and yep, so function pointers are just pointers to a function, just like we have pointers to a string, right, where it points to the first character or the first the starting point of this of the string, right, the starting address of the string. So we have the point and the functions as well. The functions are in a particular memory as well, so we can assign a pointer to that function, in which we can then call it and then use it in our program. And there are different ways in which this come in handy. So there are sometimes when you need to call probably different functions. Okay, so you need to call different functions that perform different tasks, okay, in the functions. For example, the multiplication, addition, division function. Okay, so instead of rewriting a code um, simultaneously, like writing the one for division, writing the one, you can just use function pointers to increase the address, while putting those um, addition and subtraction functions at at an increasing order. You get, so you can increase the pointer to that particular address, and then you're going to call it and use it in your particular program. So there are different way. I think there are up to like four different main um, perspective of using function pointers. So I'll just go through the quiz now, and then we'll go through the task. Oh, my light is off. Okay, so we have to be fast. Which one is a function? Is a pointer to a function? Pointer to a function. Basically, what would be replaced is the function name. Remember, we can have this int and then a function name, right? And then we'll have close and open brackets, and then int a, float b. So we would replace it with a pointer to a function, a name, right? We replace the name here. Basically, that's just the syntax. Okay, so there's another syntax that you would want to know, but probably when we get there, I'm not sure we used it in this task, but when we get there, we'll talk about it. All right, so the next thing is, what does a pointer to a function point to? Okay, it points to the code, because it's going to point to the code, and then the first byte of the code of the function. Okay, let me move this guy, and then the first byte of the code of the function. And then if f is a pointer to a function that takes no parameter, okay, and returns an int. So it's just what we did. We have the function name, right, and then the braces, but because it has no parameter, so this guy will not be filled with anything. So function pointer, we can also declare it by just writing the pointer name, and then there's a reason why we do that as well. I think basically because it still get assigned the address. I think if we go into it deeply, we would get to understand, probably in one of our online classes we're going to touch that. All right, so also we have this void, and you can see this guy is pointing. This is a function pointer already. So um, so they are not saying, what is this pointer? It is an array of pointers. Okay, as you can see, array of pointers to function that takes in an int and float as parameter and returns nothing. As you can see, returns nothing. Almost everything says returns nothing, and this. So this one says a pointer to a function, but this one is an array of pointer. All right. So we have the next one, who says to store the address. So let's say this is a function. Okay, so to store the address of this function, what are you going to do? To the variable f of the type pointer to a function that takes, so f is the pointer, right? So f is the pointer of this function. right? So you want to store the address, and you know, ampersand is the address of of operator. So we have the ampersand and the and then neo, right? So this one would save the address to F, and also neo itself also is what I wanted to explain in the first in that particular one I said probably online class, where you can also have F. Alright, so this name itself is also the address. Okay, so you can use this too as well. So we'll go through the task and let's get into it. So the first thing I want to do before even reading, I want to create this guy, create my readme, create my gitignore, because I love gitignore, and file. So I'll come here, it's loading. So while it's loading, okay, so I'll create a directory. Where is this guy still loading? Alright, so cd our ALX low level, and then we'll make directory, call it this. It's hanging. It's hanging. What is going on with this thing? Let me just reopen another tab. So I get the same box. I don't know why it's hanging. Alright, while that one is wasting our time, let us go up and check the question. So this one says write a function that will print a name. Okay, so we should write a function that prints a name. Alright, so it's going to print a name. So this is the prototype. This guy is still frozen. What's going on with this internet? This one is still frozen. Let me just close it. So ALX low level, sorry, cd make directory. So that one actually created the directory, but it didn't work. Sorry. So we've created the directory. So the first thing we'll create our readme. What am I pressing? Vi readme. Why is my V not pressing? What's going on? So let's still keep that one there, just for it not to be empty. Okay, so we have our readme already, and then let's go through. So at the end of the day, we are going to have another file called this, and then we are going to have our header file. So if you look at the main, you will see that they include std io.h and also include function pointers.h as their main.h. So we are going to use this as the name of our main.h. Okay, so we create our main.h, vi this. Alright, then we would say define, no sorry, if not define, we can just say let's call it function pointers, and then we'll say define function pointers. Alright, this guy there. Alright, and then we'll end if. Alright, so we'll copy that prototype and paste it here first. Okay, good. So we are done with this. So the next thing is we can escape. Alright, so clear. Good. So the next thing we want to do is we'll create our file and then we'll read the question. Alright. So we have to print name, right? So vi this guy. Alright, so we include our function pointer dot each. Let me copy that in very well because I don't want mistake. Function underscore pointers dot each. Okay. Function underscore pointers dot each. Okay, so we'll do that and then we'll go through the task. Okay, so it says that we should this is the prototype given, right? So let's just write a function that prints in it. Alright, so we'll go here and then we document, sorry, and we'll call this one, what's that prototype? Do I still have it here? No, it's the name I have. Let me copy it. Okay, so the name is print underscore new. Sorry, I'll call it a function that prints new, right? Alright, so we have our at f. So this is the variable to hold the starting or the string name. Okay. Alright. So basically, look at this guy. This guy is a function pointer, right? So he's pointing to a char, right? It's pointing to this guy. Alright, so this char name is a pointer, right? Holding the string name, right? So basically, print name is a function that holds a particular name, right? So this is a pointer pointing to this guy, right? So and then we have its name, which is the so we have name, we have f, right? So name is the name of the person. So this function would hold this guy in the normal sense. So this one exclude this guy for now, right? So we just have this one and it's going to accept a name, and that's the name. So we now have a function pointer, right, pointing to this guy, pointing to or to this point to this string, right? So we enter and then it's going to have no return. So you can end it like that. So we come down and end this one, go down to our curly braces, and yes. So let's see if you have no other instruction given. So what we are going to do is we're going to say that if we just check if our string is empty, okay, and if so we want to check if what they pass to this name is empty. So if that's it, it should just return nothing. Okay, so if our name is null, okay, and our function pointer is also null, when it contains nothing, it will be null, right? So when the 2 is null, it should what? It should just return. It should return nothing. Okay, so good. But when it is not, it should just print out. How do you call the function pointer? This guy, and then you pass in the parameter to this guy, right? So you just say f name, and that's just all. So you could also do f, I think like this, and pointer. I think you can do something like this as well. Yeah, I think you should be able to do something like this as well. So it's just preferable since this one is less stressful. So you can try this and let me know if it works. Alright, so I think this is all for now. Okay, I might want to, because I'm using null, I might want to use add uni std, and I want to add stddef.h to make my null work in my header files. Let me list. So I can pi my function pointers of h. I can add I can tell it to include stddef, I think, .h. Okay, so this would make that work. So I think this is that. Okay, so the next thing I'm going to do now is my main to test it. So we have our 0 main.c. Zero main.c. So vi 0 main.c. Good. Alright, so I'll do my git ignore. I'll say that you should not push everything that ends with main.c. And what's our executable file name? It's going to be called A. So you say you don't want to push anything that ends with A. Okay. And then let us execute it. Copy this guy. And then you paste it here. Alright. Even though I didn't bet in my file. Anyway. So if you run our A, you have hello, my name is Bob. Hello, my upper name is Bob Jr. Is that correct? Okay, good. So let us Betty our file just to be safe. So Betty 0 print. Okay, we are good. So good. Alright. So that's that. Then we can git add, git commit, and say a function that prints name, right? And then we git push, and then we clear. Alright, so that is all. And then let us check. As you all know, we used to I used to do my project second deadline. So this is second deadline already. But second deadline. So okay, checked. It looks as if we didn't check us. Anyway, it's as simple as that. You just use this guy, right? They've even declared it for you. So you use this guy to call this guy. You pass in a character to it. Okay, so that's just it. So let's go to the next one. Alright, so the next one says write a function that executes a function given as a parameter on each element on an array. Okay, so before we start that, let's just copy this file name. Is this what we need? Let me just create this file. I won't veer into it yet because no. So top trees. Okay, so I've created a file. So one main.c. Let me create this guy as well. So the executable is B for this one, the executable is probably C for this one, right? And then what's this guy? The executable is what? Calc, and the executable for this guy is what? Calc and main. Calc and main. Okay. So I'll be at my .git ignore. I say I don't want to push B, I don't want to push C, I don't want to push calc, I don't want to push main. Right? So I think that would deal with that. So I'll veer into my function pointers.h, and then I'll put on the prototype for the second one. Okay. This one is for one main.c, right? So let me escape this guy and VR my one main.c. So I'll paste this guy there to test our next function. Alright. So the next thing we want to do is what else? Get the prototype, and then we'll use it for our code. So we'll do a function pointer.h, and then come down, paste it. Yes. So alright. So what's that? Vi one array iteration. So I can paste this guy first. This. So I'll include my function pointers .h. Did I get it right? Then I'll start my documentation, and then this one is called array iterator, and then this one is iterate through an array. Okay, so iterate through an array, then we have at array, right? And then this one is what? Target array. Then we have at size, and this one is what? Array size. And then this one is what? At action. And this one is what? Function pointer to array. And does it have any return? No. So we can just say return void. So okay, so tab. So what are we going to do next? So let's go through the question, and it says write a function that executes a function giving a parameter on each element of an array. Okay, so this is an array already, right? So say where size is the size of the array. Okay, size is the size of this array, and action is a pointer to the function in it. So this is the as you can see, they have void. This action which is the pointer to the array, and then it collects an int. And as you can see, this function would stop here normally, right? So this is the array and then the size of the array, right? So a function that executes a function given. So if we go through the, if I try to go through this main, it'll be easy to digest. Okay, so basically it will go through everything and I think it will print out all the numbers. Alright, so let's just get into it. We'll declare an int to iterate through the array with a for loop. So we'll say if, and we'll say if our array is equal to null, like we did before, or if our action, which is that pointer, is equal to, is equal to null, you should do what? You should return. Yes, so this one is a normal statement. We want to check if this array contains anything, or this guy contains anything. So we want to use this pointer to iterate through all the arrays of this function. Okay, so probably we created a function array, right? So we want to iterate through that function array. Okay, like I explained when I was doing that task. That's one of the usefulness of function pointers. Okay, so we have this. Can we have this? Alright, so it's not going to return anything, so we don't have any return at the end. So we'll say for I is equal to 0, right? So we want to iterate through this guy. So we'll say as long as I is less than size, right? So if this is 10, so it's going to go 0 to 9, right? Because the 10th one will be null, right? So we'll do that and then we'll say I plus plus. Good. So we'll say what else? Then we'll call that this guy, right? And then we'll pass in what here? Array, right? We'll call this function pointer, right? And then we'll pass in the word there, which is array, right? Array pointer to array. We'll dereference it because we wanted to print it, and then that. So then while print, so at the first iteration it will print the first character of the array, and then the second iteration we want the character of the array to increase, so we'll say array plus plus, right? So I think with this we should get it right. So I don't know, probably I should put I should do this, or let me leave it as array plus plus. Let's check this and see if it works. What are we doing next? Let's compile, right? So we compile. Sorry, it's going to start from here. We compile. Okay, we have some errors. So this guy is just array. We're going to just put array plus plus. So like I said, vi this. So array plus plus there. And what else? Let me clear. We compile it. So we should have one error left. So it says that comparison of integer expression to different signedness int. Okay, this one is size t. Okay, I think one is unsigned t and one is signed t. So another way to go about this guy is just to okay, it is size t size. Okay, I just get some. Alright, if you look at this guy, it's an unsigned integer, right? And this one is a signed integer. So I can just call this one unsigned, right? And then I can use it as size t. Will it work? Let me just use unsigned int because I don't have the header file here, and I'm not sure if I can use it. Alright, so let us clear and recompile. Okay, it has recompiled, and then you see, so 0 to OX 1000, right? So let us get the file first and see. The file name is one array. So get it, so we are good, and that is just it. So we git add. So iterate through a function array. Hey, look at me. I used double here, I used single here. It has frozen. Okay, let us reload it. The network is kind of a bit bad, so the network is bad. Let's reconnect it. The network is bad, so cd into our ALX low level, and what's that file called again? We cd into our 0x0f, right? So we create commit, single, and we call it iterate through a function array. Let me just do that and then we push it. Okay, so come down and check your code. So let us see. Okay, so this one to worked, and then let's go to the third one. So this one, let's just create it. To main.c, create it, copy all this guy. So vi2 main.c, paste it there. Alright. Then the next thing you want to do is create this guy. So I'll touch it and clear. Okay, and then page up. So we need this prototype. We paste it in our paste it here. Sorry. Function pointers. And then paste it there. Alright. So the next thing is okay, we still need it, and then we'll go through our tags. So vi our two was equal to int index. Okay. So I backspace in enter. We include function pointers .h, and then we do our documentation, and this one is called int index, and then what is to search for an integer. So we'll go through the data question and we'll see what to do, and then we'll say array, and we'll say target array holding integers, right? And then we have size, right? So it's the array size, and then we have our CMP, right, which is the pointer. It's a function pointer, okay, to compare, right, searching together. And then we'll have a return. It's going to return an int, right, element match, comma, it's going to return -1 if the size is less than or equal to 0. So all these things has been given to us, and then we go through it. Alright, so if you look at the question, it says that write a function that will search for an integer. So this function basically is to search for an integer, right? So where size is the number of elements in the array, okay? So this is an array, so it's going to search through the array and see which one is integer, right? And then this one is the size, okay? CMP is a pointer to the function to be used to compare values, okay? And then index, okay, returns the index of the first element for which CMP does not return 0, okay? If no element match, return -1. If size is less than 0, return -1. So while coding, I would explain what we need to do to this guy, okay? So the first thing I'm going to do is, I think we don't have a sign here, so I'll call this one int I, okay? So I'll say if our array, right, is equal to null, like we do before, or our CMP is equal to null, then we should return -1. I think that's what we were told. So you see, if no element match, return -1, right? So it should return -1. Then we'll go again, and then we now want to use our for this time around, and we'll say for I equals to 0. Okay, we want to iterate through the size. I is less than size, and then I plus plus, right? Good. Okay, and then at the end it should return -1 as well. Okay, so what do we want to do here? This is where the logic comes. So we'll say if here, okay, so here we want to return 1 if our CMP array at index I, so it's going to go through all the elements in the array, okay, is not equal to 0. So if this guy is not equal to 0, also it should return 1. Right? It's not equal to. Why do I have to? Sorry. Should return. Okay, if you look at it very well, it says that if no element matches, it should return -1, right? If size is less than equal to 0, it should return -1, Okay, so everything it should return -1. If our size is less than or equal to 0, we should return -1. Okay, so the only time we are to return when is when we actually find a matching integer, right? So when it is not 0, it is an integer, right? So it's going to return 1. So except that if this guy is going to return -1. Okay, so if no element matches, it should return -1. So if all those things does not match the value, it should return -1 as well. If size is less than 0, return -1. Have we touched this guy? If our size, yes, if size is less than 0, we should return -1. That is when array is equal to null, we should return -1 as well. So I think we've touched everything. So basically this is just it, and then we'll git add it and say check for int. So okay, we have to test it, right? So let's check if it works. I think this one is called C. So we have one here. Okay, we are supposed to put a semicolon there. Okay. So it worked. We have 111. Is that what we have? 212. Okay. There's still one mistake somewhere. Anyway, let's go back into the code. Okay, so array is should return -1 if I equals 0, I is less than size, I plus plus. If CNP error is not equal to 0, return I, not 1. It should return that number. This is it. So you should return I, not 1. I was looking at where did I see this one from when I was checking that. So we are saying that once it is not 0, you should return that integer number, right? So I think this should work. So yeah, it actually worked. Okay, so that is it. So we can git add, git commit, and say print int. So that is it. Alright, so it worked. That's just it. So I don't know, let me just go through it again one more time. vi2int. Okay, so basically we want it to print, search for an integer and print it out. Okay, so this one will just help us see if this array is not containing anything, or this guy is not even pointed to anything in the first place, and if it's not doing that, it should print -1. Okay, so since this is the size of the array, so we want to go through the array one by one. So this loop will help us go through the array one by one. So at the first time, when it go through the array, right, it passes, we are now using this guy instead of using this guy directly. We are using this guy to do a kind of checking and all those stuff, manipulation, right? That's what pointers are for. So we do this, we pass in the value at index, the array at index 0. So it's going to check, is that array 0, or if it is 0, it's going to return -1. If it is not 0, it's going to print it's going to return that value to us. Okay, so that's what it's going to do. All right, so let me see if this one. So CMP is the pointer. Int index return the index of the first element of which CMP function does not return 0. Okay, so does not return 0. So that is what this part is explaining. So if no elements match, it should return -1. That is the first one we did. And then if size is less than equal to 0, so if it is 0, like that one that we did that condition, the second condition would return -1. Okay, I think we do not equal to 0. I think here we can also use less than equal to 0 as well. I think that might work, so you should try that as well and see if it works, because I don't want to waste time. Let's go. So the next one, we have 2 more to go. So the next one, write a program that performs simple operation. Okay guys, this number 3 was actually giving me serious headache, because I think yesterday I was rushing, so I had to do it and I got one error. On redoing it today, like everything was not checking. Okay, so I had to just record and stop the I'll be continuing from here. I'll just re-explain. So this number 3 will now have a code along, right? So it actually took my time, right? Because I was rushing yesterday, and then today I just don't know what happened. Okay, so basically if you look at the question, because I think I might have skipped that part in the video, because I just want to make the video shorter. So the question is that we want to actually perform a simple calculator to add, subtract, multiply, divide, and modulus using function pointers. And then the other thing is, when they are trying to execute these commands, you notice that they are giving it to an argument to main, which is you run your calculator and your 1 plus 1 give you 2, not 1 plus 1. You understand? So the first thing is, we are going to create a function, what's it called? Not operator for, yeah, I think operator function. So yes, operator function. So these 3 operator function, look at the prototypes. We have 5 things. Then you create a function that adds, a function that subtracts, the one that multiplies, the one that divides, the one that does modulus. So I'll open these 3 operator functions and then you'll see, and then I'll go around with it. 3 OP functions, right? So if you look at it, you have your header file, which is calc.h according to them, stdio, stdio. So operator add, they've given us all these prototypes, right? So A and B, and then return. So we say return A plus B, right? So we do for subtract the same way, right? OP sub A minus B. We do documentation for Betty, and then you do this as well for multiplication, and then for division, and then for modulus. Okay, so it's as simple as that. I think this part is simple. For simplicity, the next thing is the header file, right? So for the header file, we'll have this. Where's it? Yeah. So the header file, we have to use a struct in our operation, in our code. So they've given us the struct. One should start as the operator, and then this one starts for the function, right? And then it's being type def, right? So instead of using struct op, the new name will now be op underscore t, right? You can still use this struct op anyway, but op underscore t will just be better, right? So you can give it a new name, and then you can start working with OP and F, right? So so you add that to your H, and then all the prototypes. As you can see, it says this file should contain all the function prototype data structure used by the program. So you put this guy, and then you put all these prototype 1 2 3 4 5 and then 6. Okay, so you put that prototype, and then if you vi 3 is it calc.h, yes. All right, so you see we have if not defined, define, and then the struct that we were given, and then all the prototypes, right? And that's all. So we are left with 2 files, right? So the next thing we're going to do is we're going to create another file. Okay, so we've done this calc.h. So this okay, we've done operator. So there's 3 get operator function. So this one would get one of this one. Okay, so this one will be the pointer function that would help us fetch in anyone. Okay, so we're just going to create probably like a function array that we can say, okay, if it is 1, it's going to be plus, you understand? So depending on the probably operator we say we need, operator are just multiplication, division, all this stuff, addition, multiplication, division, modulus. Okay, so depending on the operator we want, it will, the pointer would the function pointer would select any of these functions for us. So we can use kind of an array to select those functions. So we can say you should pick from array index 1 like that, index 2, index 3 like that. Okay, so that is what we will do. So the get OP function, so let's see if we actually get OP function. All right, so the get OP function, we were already given this. Let me see, Windows. Okay, let me just split the screen. Okay, and what should we do here? I'm supposed to open a tab, but anyway, let me just do it. Let's get OP function. So the get OP function, we were given this already. Okay, so we were told not to use for loop, while loop. We should not call all these things. We can't use them. We can use do while loop. You cannot use switch. You can only use one while loop. Okay, so we're already given this thing, and then we can only use one variable. Okay, so if you look at it, we have all we were given except just this additional line, right? So this place we initialize I to be 0, and then we say that, okay, so look at it. So you say that while OPS, right? OPS is the name we gave to the struct that we'll be using. While OPS.op, that's index, we are trying to access what is inside the OP variable, right? Is not equal to null, and what is inside, right, is not equal to s I++. So it's going to iterate through everything that is inside. Okay, while it is not this, it should return the OPSIF, right? So let me see. So basically what we told it there is based on this struct that we are using. Okay, so we said OPS index I dot op, right? Why this guy? Okay, so it's going to check for the character here, right? And then if that character is not null, it means there's something inside, right? And also if the character is not s, where do we get that s from? Trying to remember. where did I get that? Okay, from this guy. Okay, it's not this guy. Okay, so it should keep increasing, and then once it's not this, it's going to just leave this without OPSF. Right, OPSF. Alright, so that's just what you give it. It should return the operator if it does not match any operand. That is, if it doesn't match any operator. So this is the command to say, okay, if it doesn't match anything, it should return the operation. Okay, should return it. And then the last one is this one, which we say 3 main. 3 main.c. So this one should do the maths for us. You are not allowed to code any other function than main. So this one is this is the one that will give an argv. Okay, so let us via 3 main. Alright, so I actually wrote some things to help us. So this one is simple. We are going to do our argc here and our argv. So what we did is we created a char op, and we have 2 numbers. So we said that if our argument is not up to 4, we should print error, because we need 4 arguments, and as you can see we have 1, 2, 3, 4. Okay, so we have 4 arguments, and then what we did next is we assigned the value of each these guys, this one to arg1, this one to arg2, and this one to arg3. Okay, so we assigned num1, which is the first number, arg1, the operator arg2, and then num2 arg3. Alright, so we said if operator not in operator list, so this one will check if the operator is not in our operator list, and then it should print error. Okay, so if it is equal to null or this, it should print error. Alright, so if you try to divide by 0 or print or modulus by 0, it should still give error 100. So if our op equals to divide and our num2 is 0, or our op is modulus and num2 is 0, it should print error and 100. Okay, and then at last, if all these things are not there, then you should come and print the number, the total number, which is what our we call our get operation function. We pass in the 2 number and pass in the operator, and then this would help us do the maths. Okay, it's going to do the maths for us, multiply, divide, depending on the operator we pick here. Alright, and then this one is where we did in this last guy over here, get operator function. So this get operator function is the one that would help us select which operators, okay, that we would use to do the maths. Okay, so once it selects the operator, then it's going to go back to this function, op function, and then do the maths. Okay, so it's going to call the op function and do the maths, and that's just simply it. So let's go to the 4th one, because we actually wasted time. So this one should not waste our time. So write a program that will print the opcode of its own main function. So opcodes are just like a machine language or something. Okay, so what I'm gonna do now is I'll go here. So vi first, let me get the name. So go through it and see what we can do. Copy, or let me just touch it. So I'll come back and meet you. Alright, so Okay. What a alright. Usage dot main number of bytes. Alright, and then output. So if you can see, this guy looks is like an argument to main as well, right? So this is what we're going to use: argument to main and alright. So the opcode should be printed in hexadecimal lower. Each opcode is too long. Blah 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 blah. Alright. So what we do next is we say the OP code should be printed in hexadecimal lower. Each code is too long. So you're not allowed to use printf at all. You have to use atoy to convert the. You have to use atoy to convert the argument to an int. So wait, you said you are not allowed to use atoy, and you are saying that we can use atoy. Okay, probably just to convert. Okay, if number of argument is not correct, one print error. If the number of bytes is negative, print error. Blah blah blah. Okay, good. Alright, so let's get into it. I think this is all we just need. Alright, so first thing I'll include my standard IO input output.h, and then I'll include my standard library. Alright, so I want to print opcodes. So are we giving any prototype? No. Okay, so if you look at it, it says that opcodes to main. Okay, output format, the opcode should be printed in hexadecimal lower. Each opcode is 2 character long. Okay, listing end with a new line. See example. Okay, so it is 2 character long, as you can see, contains character and integer. Alright, so we can just create an opcode. So for now I'll just say print up. Let me just say this one should be print underscore opcodes. So this one will be the one to print the opcodes of the program. Alright, so we'll have, let's just have E, A, and A, which will be the address of the main function, and then at N, which should be the number of bytes to print. Alright, so we have no return. So return will probably void for now. Alright, so we'll say void and then print underscore opcodes and then our parentheses, right? So what are we going to do? Since we are printing hexadecimal numbers, and also we'll just say A writes, comma, int n. Okay, so the next thing I will say int I. Okay, for okay, not done anything yet. At the end, you should print f new line. You can also use put charted. Alright, and that'll be all. Okay, so I'll say for I equals to 0, as far as I is less than n, I plus plus, and then I'll print f. I'll print, I want to print an hexadecimal number for every index of AI. So I'll say this should be this percent HHX. So I'll do it to 2. So dot 2 to 2 decimal place, put comma and AI. Okay, I think I'm done with that. And then so if it gets to the last part, if I is less than n minus 1, then what should they do? You should print a quote. So we should print f with space. Okay, there should be space in between there. Alright, so what I did here is just based on this guy, right? So we want to print an hexadecimal number. Okay, so based on the number of inputs that we have, so the opcode, so it's going to print an opcode, right? If the number of arguments is not the correct error, print error. The other ones you don't know them now. Number of inputs. Okay, so we want to write a program that prints opcodes. So it's just like print a number, right? Print a number, print something. So we just go, this is the number of opcodes that will be given. Okay, and if you look at it, these ones are separated with space except the last one. So to exempt the next one to be separated, we will say when it is less, as far as it is less than n minus 1, you should keep printing space. So once n is 100, once it gets to 99, it will not print space again because the last one is the null, right? Oh yes. Okay, so it's less than n minus 1, yeah, so it's okay. So and then this one will iterate through and then print whatever is there. Alright, so the next one we'll do is we'll have an argument main, and then we'll say this one will print the opcodes of its own main function, and then we'll have our argc which is the argument count, and we have our argv, which is the argument vector. Okay, so the next thing is we're going to return always 0, always 0. Yeah. Alright, so we have our int main, so we have int argc and char. Argv, right? Good. So we'll have this, and then I would say int n. Okay, so if our arg c, our argument count, is not equal to 2, right? Because it will start from 0, right? If it is not equal to 2, then you should print error followed by a new line, and then it should exit 1. It should exit 1. So we'll pass n to our toy function for our first argument, arg v at index 1. Okay, and then we'll say if that one is, if our n is less than 0, okay, if our n is less than 0, if n is less than 0, that is, if the number is negative, it should we should print error as well. And then we'll exit 2. Okay, and then lastly, so we should print up codes to put a character. So we'll pass it to our main, comma n. Okay, and then we return 0. So what we did is we called the print, we use the function pointer. So normally we just do char this and then our n, right? But now we are passing this char the address of our main because we want it to. So this and is the address of main, right? So we'll pass it the address of main for it to get it and then use it for its printing. So alright, so if we bet 100, okay, I think we have one error for the return of mail. Oh, sorry. Oh, sorry. I used colon there. So I'll do this and let's try again. Alright, so the next thing we're going to do is compile. Do we have any compilation stuff here? So just GCC. Okay. So run error main. Do you have any argument? Main 21. Okay. Main 30. Main 4. Okay. So it's going to print hexadecimal for us in two places. So is this start of it? Let's see. Oh, we have it. Anyway, let's get add. Need commit. Okay. And what should we call this guy? It's just a program that prints upload the information, and then we push. Okay, so I'm still going out today, so I have to be fast. So after this, I'll try and quickly do the variable functions, right? It's a variable functions that it's called. So we have some errors. Okay. Let's go through it again. VI 100. Okay, so we include our stdio standard library print opcode an void print opcode int I for I0 I is less than in I plus plus, and then we print the 0.2 hhx, the 0.2, and then a1, and then if I is less than n minus 1, print space, print new line. Okay, so our int main argument int n, if argc is not equal to 2, to print error exit 1, and then n equals to argv1. If n is less than 0, you print error new line exit 2, print of codes just that. So what's wrong with our code? Can't find anything wrong with it yet, except to have petty error, which we didn't. Yeah, we don't have petty error. I'm not sure what our error is, but let me use this guy. Alright, so git add, git commit, git push origin. Alright, so let's check again. Still have the error. Which error now? Still this one. So what could be wrong? SVI again. This anything stdio stdlib to each print updates. Okay. Okay. Okay, let's check. Okay, that's passed us. So basically what we did is vi was it 100. So I actually recorded it. Um, it's still the same thing. Int I for I, because 0 is less than this. Print exa. If this print space print new line. We have our argument to a int n. If not equal to print error. If n is not equal to at all. Same thing. And I don't know why that one wasn't checking before. Anyway, so that's all for that. So we'll go to the next one. Alright.